I start my day 6:45, 7 in the morning. Check my inbox, emails, and usual stuffs, right? And then I would go into my daily report. So we have production data from the other day, and I have to analyze the numbers. I want to make sure everything is all right. There's no issues, there's no downside trends, and whatnot, right? And then I'll prepare the presentations for the morning meeting at 8 every day. Safety is something very important in mining. It's very sensitive. So every morning we gather together as a team, and then we presented a topic for safety. So I prepared the safety topics, and then I presented the numbers. What are the productions we had the day before? How was the performance of the mill? What are the grades and recovery of the copper or gold that we are getting from the previous shifts and whatnot? So it probably take about an hour and a half to complete all the tasks in the morning, and then I move on to the next daily duties, such as um, dealing with projects. Right, we have different projects for different engineers, and then I have to deal with a lot of suppliers because we order a lot of chemical reagents, miscellaneous items for the machines and the equipment. So I deal with a lot of suppliers, and then sometimes in the afternoon I usually spend some time to walk around the process plant, right, and then talk to the operators, just kind of like double check if there is any issue with the equipment, if there is any leakings, any technical issues with the machines, and if there is, then we have to troubleshoot and find the solutions to get it fixed for the next operation day. And then, beside day-to-day operations, I'm also involved in managing a little bit of projects. So as a company, we have limited amount of money too, right? So we have to make a decision in terms of which project that will go forward. And then yeah, one of the tasks is to kind of like analyze the feasibility of the project, how much revenue they will be getting from executing the project, and how long is the payback, what is the IRR, and whatnot. So I think if you never been exposed to mining, it's kind of hard to visualize to understand better how it works. And that's kind of like one of the biggest challenges when I first entered the program in my second year, right? Because it's very hands-on, it's very specific. If you've never been to site to any mining operations and you don't see it by yourself, it will be very hard to visualize to imagine how the system works. So the best way to accommodate, and to overcome the challenges, we had this sort of field trip from EBC in our program that brings students to different mine operations. So they get experience, they get exposure, and they better understand the system. Yeah. And I also want to add in co-op program, which is like internship is really helpful to gain experience.
Glad you mentioned the latter part, which is about co-op, Jordan. Can you explain a little bit about that co-op program? Because I think you're right. I mean, a lot of times people understand better once they can envision it, or once they can grab a hold of the concept, the aspect, metaphorically speaking, or even in an actual sense. Can you explain a little bit about co-op and how does that help you in terms of your learning?
Right. Co-op is sort of like internship program from a Canadian school. It's optional. It's not mandatory. And then usually it's very helpful for engineering students. We have a different durations. It could be 8 months, 12 months, or 16 months, or even longer. It took a 16 months of co-op, so that's why I kind of like delay and push back my graduation by a year. But it's a very useful program. So basically, students are given the opportunity to start finding job on their own. Applying jobs, starting preparing a resume, a cover letter, and stuff like that. And then the university will provide you assistance and support, and give you advices how to improve yourselves and what are the tips and tricks to excel in finding jobs, right? So you apply for jobs, and then if you get an interview, and if you nail it, then you get a job, right? So and they pay you as well. It's not a volunteer. It's not a free job. It's paid full time. And once you gain experience, once you understand and complete your co-op terms, I would say you have a better understanding and a better vision of the industry works.
One of our new engineering and fabrication programs to give you some of the highlights. So first of all, this program, the program length is 2 years, and the required credits for students to complete that 2-year diploma is 68 credits. And the intake semesters, they are open for new students to join the program in each September or in January. The admission type is the limited enrollment program. That means that the student will have to have higher than regular college admission requirements. So on average, then the student will have to at least to achieve a B grade in order to get into this limited enrollment program. And the program in overview is students will be covering the first and second year courses. During the first year, then they will be doing the university required engineering foundation year courses. During the second year courses, then they will be covering some of the courses, and also they will be able to do some hands-on lab work. So to develop some practical skills. And this program guaranteed the students to move on to the universities. And we have this guaranteed transfer agreements with UBC Engineering and UVic Engineering. However, we do not have the guaranteed transfer agreement with Simon Fraser University, but student can finish the first year foundation or engineering required courses, and then they can transfer to university under the competitive stream, like Yanni did. When he finished Douglas College study, only within 1 year, then he will be able to move on to UBC to continue his second year study. So through this, our engineering and fabrication technology program students will have opportunities to do lots of hands-on work. So they can design the work and they will be able to execute their project by operating different machines. For example, then we have the 3D printers, water jet cutters, for example, and this is the welding machine, and also this is the water jet cutter, and student will be also using the laser cutter. Those machines, those labs are available for students to use.